Hello dear viewers, you are most welcome and thanks for watching. This is LJ2 Mathematics channel where we upload content of mathematics as a subject. So please, if you are new to this channel, kindly subscribe, turn on the notification button so that you are notified whenever I upload any video, like and share. In this tutorial, I'm introducing you to logarithm. That's why you have introduction to logarithms. And you have to know the meaning of logarithm. So we are saying that a logarithm of a number to base x is the power to which x must be raised to give the number. E.g., for example, we have m being equal to x power n. So this implies that log of m to base x equals to a. We can have more examples. The same way, if I have y to power 2 being equal to a b, it implies that in terms of logarithm, I am having a log of b to base n being equal to a q. So we can see that from here, this is the power. It's the power as you can see from this side. Then this is the base. Then this is the number they are talking of. The number that if we get this base, which is y, and we power it by q, we are able to get the number which is b. So we are going ahead to say that logarithms appear in all sorts of calculations, maybe in engineering, science, business, and also in economics. Before days of calculations, they were used to assist in the process of multiplication by replacing the operations of multiplication by addition. Similarly, they enable the operations of division to be replaced by subtraction. So, in other words, they are talking of how logarithm could help before the days of calculation came about or came into existence. So, we can proceed now by talking of the laws of logarithms. And in here, we have 5 of them. We have listed them from number 1 to number 5. We have law number 1, log of x to base a plus log of y to base a is the same as log of xy to base a. Then number 2, we have log of x to base a minus log of y to base a, the same as having log of x divided by y to base a. Then law number 3, in the case we have log of x raised to power m to base a, the same as m multiplied by the log of x to base a. Then we have number 4, the log of 1 to base a or to any base is the same as having 0. Then the last one, we have the change of base law, which states that if you have now a log of x to base a, is the same as the log of x to base b divided by the log of a to base b. So in here we have converted this log of x to base a to be in base b. So this is a change of base law. It's also important to note the following. You can have one, that if I have a log of a to base a, is the same as having log of b to base b, and it's also the same as having log of 7 base 7, and the same as having log of 10 base 10, which gives us a 1. So if I have the number of the log equivalent or the same as the base of the log, automatically the answer becomes a 1. We can now have number 2, not number 2. If I have the real of a positive number, this is the same as having the logarithm, the natural logarithm, or the log of a to base e, and this one is read as the natural logarithm, which is the same as ln. We can have number 3, also having log of n under root m to base a. This is the same as having the log of n raised to power 1 out of m base a. So if this is simplified, it means that it is also the same as having 1 divided by m multiplied by the log of n to base a. So this is also important to note it. We can have number 4. It is also important to note that log of m divided by n to base a is also the same as having the negative log of n divided by m to base a. You can see here we have interchanged. So here it is the m which is the numerator. Then on the right hand side, m is the denominator instead of being the numerator. Then let's have number 5. Denote number 5. If I have log of b to base a, this is the same as having the log of b to base b divided by the log of a to base b, which is the same as having a 1 divided by log of a to base b. So it is also important to note it. Let's have examples. So examples, we have number 1. Show that, so we have part A, show that log of m n to base a equals to the log of m base a plus log of n base a. So as you can see here, let's just straight away have the response. We can have the response here. Part A, we are required to show that the logarithm log of m multiplied by n to base a is the same as having log of m base a plus log of n base a. So from here we can start by letting, so let maybe the log of m base a be equal to the x and the log of n base a equal to a y. This implies that our m equals to the a raised power x and also that n equals to a raised power y. Now from here, what we are going to do, let it be equation 2 and this one to be equation 1. Let us multiply equation 1 by 2. So we are doing what we call multiplication of equations 1 and 2. So if we multiply them, we are going to get the m multiplied by n being equal to the a raised power x multiplied by the a raised power y. And now if we follow the rules of indices, we are going to have the m multiplied by n being equal to, so if the bases are the same and it's multiplication, we add the powers. So we are having a raised power x plus y. Then from here, what we are going to do, we are going to introduce logarithm to base a on both sides. So we are introducing log of base a on both sides of equation. So this implies that I'm going to have the log of m multiplied by n base a being equal to the log of a raised power x plus y by base a. Now there is a rule of logarithm which says that if this is a power, this one groups this side, implying that we are going to have the log of m n base a being equal to the x plus a y multiplied by the log of a base a. But log of a base a is the same as a 1, implying that the log of m n base a is the same as having x plus y multiplied by a 1, meaning that our log of m n base a equals to the x plus y. But earlier on, from where we said that we let the log of m base a to be x and also the log of n base a to be y, implying that as we go back here, it means that our x equals to the log of m base a and the y equals to the log of n base a. So as we substitute in, we are going to have the log of m n base a being equal to the log of m base a plus the log of n base a as required. So we have now shown what they wanted. This is what they wanted us to show from number 1. So it means that that's how we could prove that. Then let's see number 2. We do the same to number 2 for part B. So for part B, we are required to show that the log of m divided by n to base a is the same as having the log of m base a minus the log of n base a. So this is how we are going to do it. We also start by letting, so let maybe through x be equal to the log of m base a and y be equal to the log of n base a. So this implies that our m equals to the a raised to power x. Let us make this equation 1. And also our n equals to the a raised to power y. Let's make this to be equation 2. Then since it is involving division, what we are going to do, we are going to divide equation 1 by equation 2. So this implies that I'm going to have m divided by n. So this is equal to, so I'm going to do the same, is equal to the a raised to power x divided by the a raised to power y. As for the rules of indices, this implies that our m divided by n equals to, since the bases are the same and it is division, it means that we are going to subtract the powers. So we are going to have the a raised to power x minus y. Then from here, we are going to introduce a log base a on either sides of the equation. So this implies that I'm going to have the log of m divided by n, but of base a being equal to the log of a raised to power x minus y to base a. So I simplify this. So this is a power. It means that this will come this side. We are going to have the log of m divided by n base a equaling to the x minus y multiplied by log of a to base a. But log of a to base a is the same as 1, implying that our log of m divided by n to base a is the same as having x minus y, the whole of it multiplied by 1. This is the same as having log of m divided by n of base a being equal to the x minus y. But we said earlier on that x equals to the log of m base a and our y equals to the log of n base a. So this implies that our log of m divided by n base a is the same as having the log of m base a minus the log of n base a. So this becomes our correct expression, so as required. So this has been part B. So this is the answer. That's how one could prove that. We can now go to part C. So they require us to show that, as you can see from this part C here. So we do the same. This is part C. They want us to show that the log of m raised to power r base a is the same as having r multiplied by log of m base a. Still, we proceed the same way. Let us let our log of m base a be equal to x, implying that our m equals to a raised to power x. Now from here we can make this to be equation 1. What we are going to do, we are going to power equation 1 by r. So it means that we are going to have our m raised to power r being equal to the a raised to power x, but the whole of it, there is another power which is r. So this implies that we are having our m raised to power r equaling to, as for the rules of indices, the same as r x. So from here we are going to introduce log base a on both sides. So this implies that I'm going to have the log of m raised to power r of base a equaling to the log of a raised to power rx but base a. So as for the rules of indices or logarithm, this power is gonna drop this side. Besides that, we have the log of m raised to power r base a be equal to the r x multiplied by log of a base a. But we know that the log of a base a is same as 1, implying that we are having the log of m raised to power r of base a being equal to the r x, but our x equals to the log of m base a, implying that our log of m raised to power r base a is the same as having this r multiplying by our x, which is log of m base a. So this is the expression they wanted us to prove, so as required. So this becomes the proof for that. So we are left with part D. So you try out part D. And please drop your comment where you find problems or any challenge. And thanks for watching. Next time we shall pick up from there. See you again. Goodbye.